I'll begin my presentation for Line Developer Day 2021. Hello, presenting Shield Protect from Abusers in Line Timeline. I am Ju-Hong Lee of Shield Dev Team. The agenda for this session is, first of all, I will share some information about Shield, then I will present on why we need abuse detection, then I'm going to present some cases of abuse, followed by an explanation of how Shield detects abusers. Lastly, I will share the current status of detected abusers and Shield's future plans. First part is about Shield. These are the tasks currently carried out by Shield. They are abusing detection, text filtering using NLP, and developing and operating text filter agents and abusing penalty history admin. We began Shield in February 2019 to stop abusers using the timeline comment section. The first model started its operation in March 2019, and in 2020, the model was applied to story and birthday card. We are preparing a new model to be deployed in 2021 and will be adding new models in the future so Shield can continue to serve as a strong shield for Line. This is Shield's objective, make brighter green for Line. As it states, our goal is to make Line's services cleaner and brighter. Now, let's take a look at why we need abuse detection and some examples of abuse cases. Why do we need abuse detection? The reasons are as follows. Users only want to see what they want to see. Users do not enjoy seeing ads and comments that are meaningless to them. Users want to feel comfortable while using our services. I believe users will feel more comfortable if there are no offensive content such as profanity online. Users' emotions must be protected. We will lose users if they feel emotional discomfort while using Line. Here are some cases of abuse that use the comment section. The first case is about an abuser who generated more than 2,000 comments within 1 hour. In the case of this user, there is a possibility that his or her target was advertisement. Second case of abuse is about an abuser who meaninglessly counted numbers in the comment section in a short period of time. An example would be that if the abuser counted up from 1 to 100 and left a comment for each number. These types of cases, their intention is unknown, and it is a case that occurs more often than you think. Third is a case where the abuser wrote unknown strings as a comment. In this case also, many comments are generated in a short period of time, and same as the second case, the intention of the abuser is unknown. Now I'm going to briefly introduce the method used by Shield to detect abusers. This is the structure Shield aims to establish. We're trying to do the configuration so that there is a layer that can process data from multiple logs accumulated in Line in real time, and data storage for accumulating intermediate data, and a layer for data analysis and anomaly detection. Currently, data infrastructure, rule-based abusing detection, and ML-based abusing detection are in operation. Aggregation table is formed based on an aggregation module, and it is planned to be used in the ML model. Shield operates two types of models, rule-based and ML-based. The two types of models have similar workflows. With the rule-based model, when a request comes in from the service team, the content of the request is analyzed and the analysis is shared. In the process of sharing, the threshold is set, and this is the tuning process. During the tuning process, a rule can be discarded. However, if a rule is not discarded, it will result in an actual disciplinary action. The ML-based model starts not from an external request, but rather from an internal research. An algorithm is studied, and after it is implemented, it is verified through a collaboration with a monitoring team, then tuned. The process after that is the same as rule-based model. However, in the case of ML-based model, it is also used for the alert systems. Alert system is a system to send warnings instead of taking a direct disciplinary action. Currently, it issues only reports. The purpose of the system is collecting and analyzing anomaly cases in the alert system. Only the autoencoder model is in operation for now, and isolation forest will be implemented soon. The rule-based model is currently used to detect abusers in timeline, story, and birthday card. 16 cases are in operation for timeline, and 1 case each is in operation for story and birthday. For ML-based models, including the density model, which was developed in-house, dbScan, Autoencoder, and isolation forest have been implemented. Density-based and dbScan is used for issuing actual penalties, while the Autoencoder is used for the alert system. Isolation forest is planned to be implemented in the alert system this year. Let me explain the characteristics of the density-based model. As I have mentioned earlier, it is an algorithm that has been developed by our team. It processes according to the amount of usage of users at a specific time period. The data is divided into cells using the standard deviation. The number of users in the cell is used to classify the cell as normal or abnormal. But even if the cell is an abnormal cell, if there are a certain number of normal cells surrounding the abnormal cell can change into a normal one. The dots in the image indicate users. Green dots mean normal, and the red dots mean abnormal. In the image on the left, the area marked green are the normal cells. However, like yellow area in the image on the right, if a cell is surrounded by 3 normal cells, even an abnormal cell will be changed into a normal cell, and the users in the corresponding cell become normal users. Let me explain why we apply the density-based model. In the case of certain abusers, they take an intelligent approach, such as finding a rule and only playing within the limit of that rule. As you see in the image on the left, normal users are gathered together like one cluster. However, there are cases where the abusers are separated on their own, deviating from the rule marked by the red line, or clustered somewhere between the rule line and the normal users. The image in the middle is the data expressed as a histogram, and the users marked in yellow here are the same group of abusers marked in the image on the left. The image on the right shows abusers who control their usage right below the rule's boundary. Density-based model is used to detect the cases you see here. Now I'm going to explain what dbScan is. It is a density-based clustering algorithm. Unlike general clustering algorithms, the number of clusters does not need to be preset. Various shapes of clusters can be found, and anomalies that do not correspond with a cluster can be easily found. The hyperparameters used for dbScan are min points and epsilon. They indicate a minimum amount of data that should go into the epsilon that draws the circle as you see in the figure on the left. The green dots indicate core points, yellow ones the border points, and the red dots indicate the noise points. Core point is a point that satisfies both the epsilon and min point. A border point is a point that does not satisfy the min point, but is included in the circle drawn by the core point. As seen in the figure on the right, each core point can be linked to each other to form a single cluster. Points that are excluded from the cluster become the noise points and are recognized as anomalies. Abusers detected by the dbScan are similar to the abusers detected by the density-based model. However, because the density-based model uses standard deviation, there have been cases where it misses the abusers. Especially during the early morning hours when usage decreases, which increases the standard deviation. As a result, the size of the cell becomes bigger and more users get included in the cell rather than being detected as an abuser. And because of this, we added a way to detect an abuser by making users into clusters. The autoencoder consists of an encoder and a decoder. As data goes through the encoder and decoder, it is reconstructed into an output that is similar to the input. However, if the gap between the input and the output is big, then the error of reconstruction is considered to be big, then it is judged as an anomaly. An autoencoder is easy to implement and can be intuitively used in anomaly detection. As you see in this image, input is given in green, And when the input goes through the encoder and the decoder, the output comes out in a shade of green that is similar to the input. Now, if a red input is given instead of a green one to the same model, there will be a yellow output, which increases the gap between the input and the output. This characteristic is used for anomaly detection. The reason why an autoencoder is used is because it is impossible to predict all actions and behaviors of the abusers, and if the request from the service team comes in late, a lot of abuse could have already taken place, which damages the experience of the users. We wanted to preemptively detect abuse in any way possible, and as a way to do that, we started alerting using the autoencoder. A special feature of the isolation forest is that it does not use density or distance. Data is randomly split based on the decision tree and then isolated. And with anomaly data, because it has less volume compared to normal data, it gets isolated easier and faster. The advantage of the isolation forest is that it is useful for high-dimensional data sets. The figure on the right is an image resulting from splitting a normal data into isolation. The figure on the left is of an anomaly data. As you can see here, normal data is dense, so it needs to be split 6 times until it can be isolated. However, anomaly data gets isolated after 3 splits. This is why we use isolation forest. Its use is not limited to certain behaviors, and our plan is to use it for alerts to detect the abusing patterns of major behaviors. This is the history of how the log stream infrastructure changed for abuse detection. At first, we used the line common data warehouse. Then we adopted Elasticsearch for near real-time detection. And this year, we adopted and are using ClickHouse. Let's take a look at the characteristics of the infrastructures. The line common data warehouse stores most of the line logs. It is easy to use and provides convenience to the users. With Elasticsearch, from data storage to visualization, these tasks can be easily implemented in Elasticsearch, but basically it is a search engine. The ClickHouse is a column-based database, and because of this characteristic, a quick response is possible. This slide is an organization of the strengths and weaknesses of each infrastructure. In the case of line common data warehouse, its strength is in data diversity and data persistence. However, there is a time delay until the data is loaded, and its response time is slower in comparison with the other 2 infrastructures. The strength of the Elasticsearch is fast loading time and fast search speed, but its weakness is that aggregation of big data is difficult. The strength of the ClickHouse are fast response speed and easy data aggregation, but its weakness is that it lacks references. The reason why we are using ClickHouse right now is not really based on its strength and weaknesses that I've just listed, but rather the reason is that the infrastructures were not used in a way that fit their own purposes. So now we have changed how they are used to better suit the purpose of each infrastructure. In case of line data warehouse, it is used to analyze stable data rather than real-time data. Elasticsearch, as its name suggests, it shows excellent performance in searching. So by utilizing its search capability, it is used for analyzing and such. In actual commercial product out there, various anomaly detection and analysis tools are provided. However, for the in-house version, this feature cannot be used, and it did not really align with the form of processing that Shield wanted to execute. We concluded that with fast response time and ease in aggregation, ClickHouse best suited the way that Shield wanted to process the data, so we are currently carrying out various tests after implementing it. Now I'm going to share the results of detection and what Shield will do from now on. These are the graphs showing the results of the abusers detected in the first half of 2021. In February and March, there were many abusers detected by the rule model and a lot detected by the ML model in June. The result shows that the rule model and the ML model works complementary to each other to better protect line. There are less number of detected abusers in story and birthday card compared to timeline. And this is because they are used less than timeline. And this is what Shield is going to do next. In the area of abuse detection, we are going to create more rules and ML models so that Line can be free of abusers. Also, by building an alert system that is easy to use and good to look at, our plan is to improve the ease of use. And by creating a scoring system to score the negative behavior of the users, we're hoping to make the task of finding users who engage in bad behaviors online easier. That concludes my presentation. This was Ju-Hong Lee. Thank you.